Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on probability, lecture number 22, in which I will discuss about the probability distribution of a random variable in probability theory. In previous lecture, I have already given the concept of a random variable. Now, with the help of particular example, we would like to try to understand that what is the probability distribution of a random variable. Let a coin is tossed twice, then outcomes are HH, HT, TH and TT. Collection of these outcomes be the sample space S. Let random variable X denotes the number of heads, and we know that random variable is a real valued function whose domain is the sample space of a random experiment, and codomain is set of real numbers. Real valued function, that is codomain is set of real numbers. Here x is a function and also x is a real valued function and domain is a sample space. Here x denotes the number of heads. That means x HH equal to 2, number of heads be 2. X HT equal to 1, number of head here 1. And in this way x TT equal to 0. Here we have no head. So value of x is 0. Since here number of outcomes be 4 and outcomes are equally likely, therefore probability of each outcome will be 1 by 4. Probability of the event containing element HH equal to 1 by 4. Similarly, probability of the event containing element HT equal to 1 by 4 and so on. Here HH be a member of sample space and functional value of HH is 2. Similarly, functional value of HT equal to 1, functional value of TH equal to 1, functional value of TT equal to 0. Now range is a set containing real numbers 0, 1, 2. Here we see that these are values of the function x. Here x equal to 2 means functional value of x HH equal to 2. Here x HH equal to 2. Here x equal to 1 means here 1 has more than one preimage. So x HT equal to 1, x TH equal to 1. Now we want to relate these numbers with probability. Here x equal to 2 means we are dealing with the element HH whose probability is 1 by 4. So we write probability of x equal to 2 equal to 1 by 4. Here the number real number 1. So we relate this 1 with probability. That means we have to find the probability of HT and TH. Means probability of the event containing HT and TH. Probability of HT is 1 by 4, probability of TH is 1 by 4, 1 by 4 plus 1 by 4 equal to half. So when x equal to 1, that means we have to write the probability of the event containing HT and TH, and that is half. Now here we want to relate 0 with the probability. Here TT be the pre-image of 0. So we have to find the probability of TT. Probability of TT is 1 by 4. So when x equal to 0 means functional value is 0, then probability will be probability of this outcome TT, and that is 1 by 4. So probability when x equal to 0 is 1 by 4. Now we frame a table. Here table contains first row x means random variable whose values are 0, 1, 2 here. That means range, elements of the range. And when x equal to 0, probability is 1 by 4. When x equal to 1, probability is half. When x equal to 2, probability is 1 by 4. And this table is a system which is called probability distribution of random variable x. Now we define the probability distribution of a random variable. Let x1, x2, xn are possible values of a random variable x, and p1, p2, pn be the probability of random variable x taking values x1, x2, xn. That is probability of when x equal to xi, that is equal to pi probability. And we arrange this table. In the first row we have values of the random variable, and in the second row we write the corresponding probabilities of the values of the random variables. So here probability distribution of a random variable x is the system of numbers such that first row will contain the values of the random variable and second row will contain the corresponding probabilities, with the condition that probability pi greater than 0 and sum of these probabilities equal to 1. Now we solve a problem. Problem is state which of the following are not probability distribution of a random variable. Give reason for your answer. Number 1. Here values of the random variables be 0, 1, 2. These are all real numbers. Here probability for x equal to 0 equal to 0.4. Probability for x equal to 1 is 0.4, and probability for x equal to 2 is 0.2. Here we see that these probabilities are all greater than 0. So this is the required condition for probability distribution of a random variable. Again, if we add these probabilities 0.4 plus 0.4 plus 0.2, and this is equal to 1. So all the conditions for probability distribution of a random variables are fulfilled here. So this is a probability distribution of a random variable. Now second, number 2. Here we see that probability for x equal to 3 is minus 0.1, which is less than 0. Since for the condition of probability distribution, we should have that each probabilities must be greater than 0. So here less than 0. So this is not probability distribution of a random variable. Number 3. Here we see that if we add the probabilities, we get 1.05, which is not equal to 1. This, for probability distribution, this sum must be equal to 1. So this is not the probability distribution of random variable z. Here number 4. If we add the probabilities 0.6 plus 0.1 plus 0.2, this is 0.9, which is not equal to 1, and for probability distribution this must be equal to 1. Here we do not get sum 1, so this is not probability distribution of a random variable y. Now we solve problem number 2. Two cards are drawn successively with replacement from a well shuffled deck of 52 cards. Find the probability distribution of the number of S's. Now we solve this. Here number of S's is a random variable. Let it be denoted by x. So x may take values 0, 1 or 2. Since we have to draw two cards successively with replacement, in the first draw it may be possible that we do not get any S, and in the second draw also we do not get any S. That means value of the random variable will be 0 in this case. Again, if in the first draw we get an S and in the second draw we do not get an S, that means we get an S. Similarly, in the first draw we do not get an S, but in second draw we get an S. Here also we get 1 S. That means value of the random variable is here 1. Again, if in the first draw we get an S and in the second draw we get an S, means 2 S's. So value of the random variable be here 2. Now we find the probability of these random variables. Since draws are done with replacement, means two draws are independent events. Now we find the probability for x equal to 0. X be the random variable whose value is 0. Here random variable be the number of S's. If we draw no S in the first draw, no S means number of S's be 4 and number of non-S's be 48. So probability for non-S means 48 by total number of cards 52 in the first draw. Again, now we get same number of cards in the deck. Again, in the second draw, if we get non-S, means number of non-S's be 48. So probability will be 48 by 52. Since two draws are independent event, so we multiply these probabilities. So probability x equal to 0 equal to probability none s and none s, and this is 48 by 52, multiply 48 by 52 equal to 144 by 169. Now second case, probability x equal to 1, value of the random variable be 1, means 1s. This is possible that if in the first draw we get an s, that probability will be 4 by 52, means number of s's be 4, so probability will be 4 by 52. Now we return back that card to the deck, and in the second draw we get none s. None s means number of cards will be 48. So probability will be 48 by 52. Since these two draws are independent events, so we multiply these probabilities. So 4 by 52 multiply 48 by 52. Again, for 1s we get another process. In the first draw we get none s, and we return back that card, none s. In the second draw we get an s. So in the first draw none s, whose probability will be 48 by 52, and in the second draw s, that probability will be 4 by 52. We multiply these because these two draws are independent events. And so we write here probability x equal to 1, number of s's be 1, equal to probability s and none s, or none s and s. For s and none s we get probability 4 by 52 multiply 48 by 52, or means union, means here plus here, mutually exclusive events, plus. And for none s and s, probability be 48 by 52 multiply 4 by 52. This equal to 24 by 169. For probability x equal to 2, means number of s's be 2, which is possible that in the first draw we get an s and we return back that card to the deck, and in the second draw we get an s. Since two draws are independent events, so probability will be 4 by 52 multiply 4 by 52 equal to 1 by 169. Here we get same probability because the card which was drawn in the first time, that was returned back to the deck, and then we again draw one s from the deck. Now we frame a table for probability distribution of the random variable. Here table is, in the first row values of the random variable 0, 1, 2. In the second row corresponding probabilities. For x equal to 0, probability be 144 by 169. For random variable x equal to 1, probability be 24 by 169 here. And for random variable x equal to 2, probability be 1 by 169. This is the required probability distribution of the random variable. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.